This is all about Stringer V26. It is a very exciting release. It is a major upgrade to Stringer in terms of what you can do with data management and what you can do take off your survey recorders today. I won't say any more because that will steal Jack's thunder. But the main part of this presentation will be about managing data using Stringer Topo. My name is there and my face is there because there will be a small section where I will be called upon to show some of the secondary features, or not secondary features, other features in Stringer V26. That's sort of what I wanted to say there. Jack, if you could just flick to the next slide. So just in terms of release, we are right on the cusp of release. Autodesk put out an update to their software, which affected our software, which sort of changed our release timeframes. But we are very, very close to release. The release goals, of course, is to support Autodesk 2026 product range. And if you didn't know, you can install it on Civil 3D, AutoCAD, BricsCAD platforms, both latest releases and back to earlier releases. So 21 is the sort of feature there. If you didn't see our session yesterday with regards to licensing, we do now have a cloud enablement, and there'll be much more about that in terms of information share upon release of the software. So that sort of rounds out what I wanted to say in terms of slides for now. I'm going to hand over to Jack to start talking to you about what's new in V26. So Jack, over to you.
Cool. Thanks for that, Shane. First off, welcome everyone. I know Shane's already done it, but I thought I'd also welcome you to the new features that are going to be released with V26, which is coming soon. So first off, we're going to be adding in support for attributed data. So anyone in the past who has looked at working with attributes, primarily this is something that JXL and XML users have been looking at in the past. We now allow you to work with the attributed data. Now, the way we're doing this is through, the ability to create and manage schemas within your drawing, add tables to objects, and then edit, review, and output the information attached to those tables from there. We'll be going through that today and looking at how all that works. So anyone who's unsure about those terms, we'll get into that shortly. Once we've gone through and looked at how you can go about attributing all the data in your drawing, we will then have a look at other enhancements within Stringer. And for this, I'll be handing back to Shane to do the demonstration on best fit alignments, points from chainage and offset, and importing a point cloud using Stringer. Adding attributes, what is entailed in this? Well, first off, you would be looking at creating a schema. And within that schema, you've got a data table, which holds basically what the object is going to be. And then you've got fields to explain further what's involved in that. For instance, if you had something like a tree, you would have the data table labeled as a tree. The fields would be something like, what type of tree is it? Is it a cedar tree? Is it a eucalyptus, a maple? Any of that information. It would also be things like the canopy, who the owner is it a protected species or not? You'd also have some default values that you can add into the data table, which allow you to pre-populate these fields if need be. And you are also able to set up a validation file. And within that validation file, you can put in values that are allowable by the software. And if they do not match the allowable values, the software will highlight them for you as you go through. Now, if you're wanting to work with multiple schemas, a common one I like to refer to here is for anyone who's doing A-spec submission. If you have multiple schemas, D-spec, R-spec, O-spec, you're able to switch between them and have them preloaded in, ready to be used as needed. So we'll actually have a look at some of that stuff today. Now, the project database is going to be what actually allows you to attach this information to these points. And the way that this works is you have all of your survey objects. Well, you can have all your survey objects already within your drawing. So you can see here I've got a little mock diagram up. We've got some points represented by triangles and some strings. You would then go ahead and attach a project database to your drawing. That would hold the schema, data table, and validator. And then those data tables get attached to the line work and to the points, or basically your survey objects, based on the codes that have been set up. So yeah, that's how that's going to be working. So how do you actually go about doing this? So there's two main methods of going about working with attaching the object information to your, to your survey. The first is to do user managed. The user managed way of working through this is going to be the first demonstration I do today. And this involves manually setting up schemas and then attaching object table mapping, which is what allows you to attach your schemas to the different points or to your different survey objects, and then importing all of that attributed data. This will be the manual method, and we'll run through that shortly. But then the other method, for anyone working with JXL or XML, you are actually able to bypass a lot of this setup, as the JXL and XML files actually hold all that information within them. Using those, you're able to quickly establish a project database, automatically create all your data tables, and populate everything rapidly using our new XML JXL importers. So schemas and settings, what are we talking about here? We've got schemas which are able to manage your data tables. So these data tables can be saved once they've been set up and can be found in the location that you see highlighted here. So Windows, C drive, program data, CSS, ARD, common 10. They live in here, and you are able to share these out to any other users of the company as needed. You are also able to set up a custom location for these if you wish, which can be set up within the software when you're setting up your project database. Data tables allow you to hold all the information, as I've said earlier. This is a real example you can see on screen here. The basic schema actually gets installed with the software, and we have some pre-set up ones here ready to go. You can see that it's been broken down. We have a number of fields represented by the column seen here. You've got data types saying what values can be allowed, and then you've got the default values that will be loaded into the software along with the validator. Now, the validator itself can be also accessed from the schema editor, and from here you're able to set different fields for it to read and check the details of. So if the field does not match the values seen within details, it does not load in. Sorry, it loads in, but it will be highlighted for you to check later on. Now, once you've set up your schema, you then need to tell it how it's going to be applied. And the way you do that is through object table maps. So what you would do is you would set up your point code library using Stringer. Anyone who has used Stringer in the past should be familiar with setting up a code library. Once that's been done, you can then assign an attribute table, attribute data table, to each code. When you're first importing, it will set the first table as the default value, and from there you are able to customize it as you need. For anyone using JXL XML, you don't need to worry about this process, as the XML JXL does this for you. Local project editing can be done once you've imported all your attributes onto your survey objects. We create a local version of the project that you can then go and freely edit and modify as needed. Once all the data has been imported, we then have a number of different commands allowing you to go and edit the survey attributes, and we'll run through those today, along with Table Viewer, allowing you to do mass edits as needed. So let's actually have a look at a proper example. So we'll be working through JXL and XML a bit later. You can see I've got one of those set up here. But for the start, we're going to say that you have gone ahead, you've done your survey, you've come back to the office, you've imported, hopefully using Stringer's import and reduce. This does work for basic data. It's just a bit of a shameless plug there. And what we're going to do is look at setting up some attributes for our points and line work that you see here. So the first thing we're going to want to do is look at what schemas do we have available? What are we actually working with? Within the ribbon, you'll see we now have a couple of new commands seen here under reduction. And what we're first going to do is have a look at schemas. So dropping this down, you can see we've got schema editor. We're going to select that option. And that's going to allow us to view any currently existing schemas. You can see here that I've got a default schema database loaded in. It's got a value of tree preset up. I've got a column name here. These are the fields we were talking about earlier. And I've got tree number, species, and canopy set up. So these are the fields that will be read in. Next up, you've got data type. Data type is saying, okay, what can the field actually be represented as? If you're working with integer, you're working with whole numbers. If you're working with text, you're looking at alpha characters, or numeric, you're looking at numerical values. So these are the three most common. If we drop this down here, you can see that we do have access to blob and real numbers. So you can switch to those if need be. The default value column that you see here can also be really good. It allows you to preset a value within these fields so that they're not coming in empty. So let's say, for instance, that species, I needed that to be populated for when I submitted it. I can put in a value of NA, just saying not applicable. And if it finds that there is no value being loaded in by whatever I'm importing, it'll put that value in for me. Last of these columns, we've got field validator. This is where you're able to assign a validator to this. So if we drop this down, you can see I have access to species and protected. Selecting one of those will allow us to validate the data. Now, the way you create these is you'll see we have a pen icon here. Selecting that pen icon will open the field validator editor. You can see the fields I have listed here are species and protected. And one thing you need to make sure of when you're working with it is the field name needs to match what you're setting it to in the column name in the fields here. So at the moment, the only one of these two that can be assigned is species, as it lines up with the species field seen here. Once you've added your field, which you can create by just going add field here, you can then set up which values are allowed under that, well, the validator. So you can see here, it would accept cedar, eucalyptus, birch, or maple. If it finds any other ones, it will highlight them once the data has been applied. Now, we've got some preset up ones for any users wanting to have a look at them. If we drop down file, you can see we've got open schema directory. Opening that up. Should open up. Okay, it's not opening here, but we do have some preset up ready to go. If I just have a look here. When you first install the software, you'll see we have basic schema, default schema, and XML JXL schema, allowing you to import a database of your choosing. So these are able to be freely chosen as needed. If we then go OK, I can drop this down to show that we can also access the field validator from here. So once you've imported your local settings, you can work with that. What we're then going to have a look at is we need to assign all those tables to the different codes so that they know how they want to be attached to our strings and our points. So you've got two different table maps to set up here, COGO, points, and survey strings. If we open up one of these, you can see here that we've got numeric and alpha pre-set up ready for you guys to use. We can create a new one as needed. So I can go add table map here, enter a new table map. We'll just call this one new. And then if I drop down table, you can see that we've got some preset up here ready for you to work with. If you do want to load in a different schema, you can go read tables from schema, allowing you to access them. and then you can attach a point code set. So if you've got a code set pre-set up within Stringer, you are able to use this option to pull in that code set. Accessing this, you can see I've got my pre-set up Stringer ones ready to go. I could go numeric individual layers, select, and it preloads in. If we look at the table here, you'll see that it's chosen the first one in the list, but I can freely change that as needed. If I go back to the numeric one quickly, if I scroll down, you can see that they've been pre-set up, ready with different tables to be assigned. You would then need to go ahead and do the same for your survey strings, as you may want these to be different. And once all that's set up, you then need to look at your project setup. So now we want to look at actually assigning these values. I'm going to drop down attribute data and look at setup project database to actually look at assigning all this data. Selecting that, it'll open up this database here. And the commands I just ran through can be accessed from this menu. I just like running them from the ribbon, as it allows me to separate everything out. So you'll see here we have Open Schema Editor, and we have the table map editors found here. If I drop down the schema here, you'll see we have access to those 3 schemas I showed earlier. I'll be working with basic schema for the purpose of this exercise, as it allows me to attach trees, electricity pits, signs, all that information. So I'm selecting that one to work with. If you want to set up a custom database location to load all this information into, you can do so from here. But I'm going to ignore that for now. And then I'm just going to confirm that my table maps are correct. So I'm working with numeric data. Sorry, that's going to be the one I work with. If I was working with alpha, I just switch that across. For anyone that is working with properties already within their raw data, and they're wanting that to be assigned to the attributes, provided the property name matches with the field name within the schema, you can toggle this option on to have that information pre-populate. So it will pull the information from the property and apply it to the attribute field. I just need to stress, though, that you do need to make sure the property name matches what the schema editor's field says. So you just keep that in mind. Once this is all set up, the process to actually attach all this data is very easy. I simply go OK, and it goes ahead and attaches all that information, all the attribute data table information, to each of the points and the strings. What it's also doing in the background is it's also creating a local version of our project. So this is all the settings that we just set up here that can then be edited on a local scale once the data is set up. So if you need to make any edits to the schema and you don't want to apply that to any future ones, you are able to do those edits after it's been imported to work on it like that. So if you want to make sure that you're now working at a local one, we can drop down the option here again and go back to Schema Editor. And if we look up the top here at the location name, you can see it says current database. This is showing that you're now working in a local space, and any edits you make will not be represented on any future drawings that you work in. It's only being applied to this one. So just, if you're not sure, just run that up. Now the data has been applied, we want to make sure that it's, well, there and ready to go. There are 2 ways to go about doing this that also coincide with how you would go about editing the data. We drop down attribute data, we have the ability to edit point attributes and edit string attributes. These are the best options if you're looking to edit on an individual level, or if you need to switch the attribute data table assigned to the point or the string. So let's just work with a point for now. So we'll find one to work with. Let's look at a tree actually. So I'm selecting this one here. You can see here that table tree has been assigned. I don't have any values preloaded into the other one, but the protected has picked up on that default value and has applied a Y to it. It doesn't match what I had within the field validator. If anyone remembers back there, we had yes and no, not Y and N. If we click here, you can actually see you have access to a drop down where you can select the value you wish for it to be. If you want to do this to, actually just going back in there, Let's just select one of the other ones for now. If you wish to change the attribute table applied to the object you've selected, you can use the drop down here, select the different attribute table you wish to switch to, change table, and that is now represented as an elect table with the different fields shown here. To apply it fully, you can go save, you'll be told that it's been saved, and that is now applied to that point. If you're wanting to work with survey strings, you can drop down this again and go edit survey attributes and select a point on the string that you're wanting to work with. In this case, I'm wanting to work with a 90302 string. So I select that point, hit enter, and it then opens up the table editor for that string, which I can then go and customize exactly the same as how I was doing it for the point. Now, some of you are probably going, cool, that works on an individual level, but I want to see all the data. I want to work with it on a more global level. Well, we do have an answer for that. If we drop this down here, we've got the table viewer. Now, table viewer works on a more global scale. It allows us to see all the data currently within the drawing and able to edit it and work with it as needed. Now, everything I show at the moment will be on COGO points, but we do also have the ability to switch to survey strings as shown here, allowing you to switch between them as needed. Next up, you've got table. So currently it's showing you all points that are found under the default table. Let's switch it. Let's go with tree again. If I switch over to tree, you can see I've got a bit more information to work with here. Column allows us to filter out that information further. So if I drop this down, I've got a series of rules that I'm able to set in. So if I wanted it to basically equal one of these values or be greater than or less than, I'm able to fully customize that as needed. Next up, we've got some information down here. So at the moment, it's gone ahead and it's found that there are currently two points that have information loaded onto species, and the yes is from earlier where we edited the point. So all that information has been preloaded. It's not agreeing with any ones that are highlighted in red as they do not match our field attribution, and we may wish to go and edit these. So you can go ahead and just use the drop downs here to do edits as needed, just filling this in. You'll see that as I'm editing them to be accepted values, it's accepting all that. Or I can use shift to quickly select everything and then use override selected. I can then enter a value of my choosing, and it's going to override that information. I've still got access to the dropdown. I can still work with that, but that information is preloaded in. I can even work with numeric values. Let's just quickly modify this. We're going to go override selected, and let's just say we got really lucky and every single one of these trees had a canopy trunk and height of 2 meters. So all that information can be loaded in, edited, worked with. You can simply click on the field, do the edits you need, rapidly allowing you to work with all this. If you want to export this information out as a table, you're able to export it out from here. But personally, I actually like doing this from a different location that we'll have a look at now. So once all that's been worked on, what we're going to do is have a look at how you can export this out. The first thing we're going to want to do is look at attaching all of the attribute information we just worked on onto the points as properties. To do this, drop down this option here again and then go sync to COGO properties. This will sync all of that information that we just worked on onto the point properties themselves. From here, we can go into point groups, and then we can look at customizing a property list for us to work with. So let's say we want to work with trees, and we want to create a custom property list to export out as either a data table, shapefile, any of that kind of information. We can customize this. So use property list, we're going to toggle that on, set up property list, and then you can go ahead and either manually customize this if you haven't set this up before. We've got a number of preset options that you're able to load in to create these, or you can create your own custom property. Once you're done, you're able to hit the save icon here to save it as a custom one. But if you're using the ones that we've provided, the databases that we've provided, you can actually go to the browse icon here. And if I just copy the location to speed this up a bit, you can see we've got some custom property lists set up, ready to go. These have all of the custom attributes preloaded in as properties for you to be able to work with. So we're working with tree here, so we're going to select that one. You can see here the extra fields have been added in. I'm going to go apply. And if we scroll across here, we can see that every single one of those fields is populated based on the attributes that we had prior. I can then go ahead and go, okay, I want to export out a CAD table. And because we've customized this, if we have a look here, you can see that the table is being represented by the property list that we just set up. So it's very easy to push this information out. If anyone's looking to export this out in a GIS format, we've also got this option here, export to GIS. Running export to GIS allows you to choose where the shapefile is going to be exported to. So if I just, again, I'm just going to choose a location here. I can export all of these out. And you can see that this is where they have just been created to. Change it to type. And just so everyone's aware, we get different tables. So we get different shape files for both our points and our strings for each of the different, well, for each of the different field tables that we created. So you can see I've got a points one for elect because I don't have any strings associated with it. But for ones like poll, you can see I've got points and strings associated with it. So it's really cool to be able to work with all that. Yeah. So that's how you go about doing this manually. For anyone, though, that's working with the XML format, we are actually able to skip a number of these steps. So with this, you're able to do almost like, as I say here, an all-in-one import option, allowing you to create your points and strings along with automatically creating the data tables ready for import, basically. So we've got two different commands for working with this. I'll switch over to my other drawing now. And these are aptly named import Trimble JXL and import Leica XML. For the exercise today, I'll be working with a Leica XML file. But for anyone using JXL, the process I'll go through today is exactly the same. Excuse me. So running this up, it's going to ask me to select the Leica XML file. Very simply, I'm just going to go and navigate to one. So this is one here. Next up, you're just going to want to confirm that your code library matches what you're going to be importing. In this case here, I'm working with an alpha code library, so that matches up here. Sadly, the job I'll be importing does not have survey strings attached to it, so I'll be leaving that one as off for now. And then we're just going to confirm that we're working with a blank database, as the information within the XML is going to be ported over. So set up project database. I'm going to select the blank one. So XML JXL schema has been set up specifically for this purpose. Again, this gets installed with V26. So if we have a look in here, open schema directory. Oh, it's navigating to it directly. This one actually has no information in it that will be overwritten. I'm going to go OK here, and then I'm going to go import points to import that XML file directly in. At the same time, it's going to be attaching all the attributes and have everything set up and ready to go. You can see how quick that was. The surface has been created. All my points have been imported. And if we have a look back here at the schema editor, we're working with a local schema. All of our information has been imported. And if we have a look at the table viewer for a more global look, we can see that we're now working with the different information, the different attribute tables. So it's a really cool way to be able to very quickly bring all that data in, allowing you to, well, quickly get to the point where you're able to start working on editing everything. Yeah, so yeah, out of curiosity, Shane, are there any questions on attributes from that?
Sorry, Jack, just hitting my audio button. No, there's no open questions at this time. So, um, I'm hoping everybody has you know, understood everything and they just have no questions. But no, there's no open questions at this stage.
All right. In that case, I will most likely be handing over to you to talk about the other commands that we are adding into Stringer with the upcoming release.
Excellent. So look, there's a lot of fixes and other improvements that have been applied, but some of the key ones I'd like to just touch on. We have improved what happens with CSA surfaces. So understanding in Civil 3D, we're often leveraging out to the Civil 3D surface. However, there is a surface engine that we also have inside of Stringer. We've basically implemented an adaptive decimate process. And what that does, it just looks at the size of the surface. And if that's going to exceed your computer capacity to process the surface, we review that surface and adaptively decimate. Basically, we look at areas where there's not a lot of terrain change, and we look at consolidating elevations or consolidating points. But the tool that I'd like to show around surfaces is that you can create a surface directly from a point cloud that's an LAS file. Again, taking nothing away from what some of the other platforms do. So Civil 3D certainly has, through Recap, access to point cloud controls, and BricsCAD as well has some point cloud tools. But certainly within Stringer, you could read in an LAS and create a surface directly from that. We also have the ability to create a best fit alignment. So if you've got survey data for a centerline, for example, we can look at fitting an alignment along that. That's potentially more of a design opportunity, but I'll show you that tool. And we also can create COGO points based on an alignment. So I'm going to create a best fit alignment so that I can show you how to create COGO points based on chainage and offset. So instead of eastings and northings or bearings and distances, we can do it based on chainage and offset. So they're they're the three tools I'd like to show. I will just make a note, even though there's not a bullet point. If you do start a project and start just from a Stringer command that's not import and reduce, we don't automatically pack the data inside the drawing. There's an option for you to do that, but it's defaulted off, so you can tick on if you'd like to embed the data inside the drawing. I think for most Stringer users, it's customary to leave the data inside the drawing, so the one DWG contains all of your survey data. So what I'm going to do now is just flick over to my screen, and
I think I have to stop sharing for that.
I think I can steal. Let's see. Everybody hopefully is seeing my screen right now.
Yep, it's just come
Okay,
through for me.
so in the Stringer Topo menu, if we have a look, we've added in surface from layers, which I'll talk about next. And we also have under site the ability to create alignment geometry. So what I'm showing right now, this command is not in Civil 3D because Civil 3D has alignment tools, but the best fit alignment tool in Stringer works on the basis of ascertaining tangents across your geometry points or polyline you provide, and then working out best fit curvature around that. It can be accessed from the menu, or if you right click on, oh, I have the wrong tool space open. My apologies. This would be the Stringer tool space turning up right now. You will see that you have alignments here to create best fit alignments. So in here, you name the alignment. I'll call it the best because it's the best fit alignment. And we allow you to create that by selecting COGO points or selecting a polyline. So when it comes to COGO points, you'll pick a point group that represents the points. And the only real requirement is that those points run in a directional sequence. So you can see that they're running from west to east, increasing order. And all you need to do is to set your radius ranges you'd like to work with. And once we press create update, what the software will do is it will lay down an alignment best fitting against that geometry. You do have certainly the ability to tweak the detection process, and the most prominent control for this is the curve detection. And what you would do is you'd slide this around. You can see that it's determining different tangents, different curves across that alignment. You'll see once you get a very low tolerance that you'll not be very closely matched, but you can slide this around until it sort of hits a sweet spot for whatever best fit you're looking for. So that is the best fit alignment tool. Probably one of the more likely elements you'll potentially use is the ability to create COGO points based on chainage and offset against an alignment. And you'll see that under the create points, there's points by alignments. And if you're a ribbon person, down here, you've got import COGO point file by alignment. So with this tool, it's just like importing points using coordinate control. What you'll do is you will pick a file. So I do have a file here, which is import by chainage offset. And what you'll see is that you have here point number, a chainage, distance along an alignment, an offset, and then a description of that point, all separated by commas. And all you need to do is to establish a file format to bring that data in. Okay, so that's the point formats command, and you'll see here that it says point number chainage offset code separated by commas. And you then just tell the software that the chainage property or the chainage input is what's for chainage, offsets for offset. You can add aside for a bit of text of whether you're left or right. But if I just click on import points, what we'll see now is that we have additional COGO points in the drawing, and those COGO points are positioned with chainage and offset relative to the alignment. Okay, so those points live and breathe in here, but their positioning is coming from the alignment. Okay, so that's those two features discussed. If I have a look at a blank drawing, I'll talk to you about using a LAS file directly to build a surface in Stringer. So that will turn up here under the CSA Surfaces node. To do this, you can just right-click in the tool space. If you're a menu person, you'll see Surface from LAS up the top here. And what this does, it just reads LAS files that you provide. Okay, so it's assuming that you've filtered those or cleaned those to your own satisfaction. But you can grab as many LAS files as you like, and then you can open those up. So what it's telling me is that there is somewhere in the vicinity of 1.5 million points contained across those two files. And what the software offers you here is the opportunity to downsample or reduce the size of the surface by applying a voxel size. So a voxel is like a pixel. But it's 3D, so it's a 3D grid. So think Minecraft, think cubes. What you're saying to the software is within a voxel size of 5 units, that's 5 high, 5 wide, and 5 long. I would like to reduce the number of points inside that voxel space. So it is a way to quickly limit surface size. If I set that to say 2 and I hit downsample, then it will give me an indication of how many points would be brought in from the cloud if I downsample with a voxel size of 2. Now, if I didn't downsample at all and it said, 6 million points, when I run create surface, it would likely apply adaptive decimate to make sure that your hardware will keep up and build that surface. But if I just click create surface, I then confirm the name. Okay, and then the surface will be brought into the drawing. Okay, so it's just processing those points, gathering out the information of the LAS. And then from that, I'll have a surface in the drawing in the next few seconds. You'll see there while that's happening, there's a note here for a link to an application that will convert LAZ files to LAS files, recognizing that when you go to sites such as Elvis and download resources, you'll often get a compressed LAS file, LAZ, so you can read that, convert that into an LAS. You'll see here that the surface is listed. If I just do a zoom extents, then we can see that that point cloud has come in. So that's what I wanted to show in terms of other new features. Certainly, as I did say, there's a swathe of other fixes we've put in, responses to customer requests, customer reported items, but that's sort of the other collection of features from V26 that we wanted to show you. So that wraps out what I wanted to show. Just in summary, from myself and Jack, thank you very much for attending, and thanks Jack for presenting the opportunity for customers to add extended data to their surveys and inherit that from what they pick up out in the field. We're certainly keen to hear from you on your thoughts on what we've created, and if anyone has any questions, please throw them out there. Jack, are there any questions floating around?
There is one from a user asking when V26 will be available. Do you want to answer that one?
Very soon, I say. Look, we're hopeful early next week that we'll have it out. As I said, we just got blindsided a little bit by some changes Autodesk made, but we think we're over that hump. So we're we're looking at next week. So I might just quietly talk us through this slide, but if there's any other questions, please avail yourself of the opportunity to ask. As I did say, we are recording, or we have recorded this session, so we'll prune out my mumbling and pop it up, so it'll turn up on the YouTube page. There are some more webinars coming up, so if you receive notification for this one, you'll be invited to some future webinars. I think the next couple are from you, Jack, around point
Yes.
clouds. Yeah.
Yes, point clouds for BricsCAD and then point cloud for Civil 3D and how
Cool.
Stringer interacts with it.
So that is certainly on the cusp. So thank you, everybody. Thank you, Jack, for that presentation. We hope you all got a lot out of that, and we're excited for you to hop into V26 and start enhancing your survey data with a lot more information than you ever could before.